So our question is to find ROC of both sided signal, and to draw it, firstly we have to know that what is ROC. ROC is nothing but the values of s, for which the integral minus infinity to infinity x of t e raised to minus st dt converges. So let us take, let x of t be, x of t is equal to e raised to minus at u of t plus e raised to minus bt u of minus t, when a is greater than 0, b is greater than 0 and a is greater than b. Therefore now the Laplace transform of x of t signal is given by L of x of t is equal to x of s is equal to integration minus infinity to infinity x of t e raised to minus st dt. Now we will put the values of x of t in this, is equal to integration minus infinity to infinity x of t's value is e raised to minus at u of t plus e raised to minus bt u of minus t e raised to minus st dt. Now we will separately integrate this. Therefore integration minus infinity to infinity e raised to minus at u of t e raised to minus st dt plus integration minus infinity to infinity e raised to minus bt u of minus t e raised to minus st dt. Now we know that u of t's value is 1 whenever we have the integration limits from 0 to infinity. Therefore 0 to infinity e raised to minus at u of t's value is 1, therefore e raised to minus st dt plus u of minus t's value is 1 whenever the integration limit is from minus infinity to 0, therefore e raised to minus bt e raised to minus st dt. Now we will take the exponential common, therefore integration 0 to infinity exponential common, taking minus sign common, s plus a dt plus minus integration minus infinity to 0 e common minus and common s plus b of dt. Now we will integrate this, therefore e raised to minus s plus a divided by minus s plus a 0 to infinity plus e raised to minus s plus b divided by minus s plus b. We have the limit minus infinity to 0. Now we know that complex frequency is equal to s is equal to sigma plus j omega. Therefore here we have to put the value of s, that is put s is equal to sigma plus j omega. Now x of s will become e raised to minus sigma plus j omega plus a of t divided by minus s plus a 0 to infinity plus e raised to minus sigma plus j omega plus b of t divided by minus s plus b minus infinity to 0 is equal to e raised to now we have to put the limits, that is e raised to minus sigma plus j omega plus a infinity divided by minus s plus a minus, here when we put 0 that becomes 0, e raised to 0 divided by minus s plus a plus whenever we put this limit into this, that will be also become 0, e raised to 0 minus s plus b minus of, we'll put minus in infinity in that, e raised to minus sigma plus j omega plus b of minus infinity divided by minus s plus b. Now we will take the imaginary and real part separate. Therefore e raised to minus sigma plus a of infinity e raised to minus j omega infinity divided by minus s plus a minus 1 upon s plus a. Therefore minus minus here we will get plus, and here minus 1 upon s plus b. Here we will also get plus e raised to with this minus infinity and minus of this will get cancelled. Therefore sigma plus b and e raised to j omega of infinity divided by s plus b is equal to, now where we have sigma plus a and sigma plus b, instead of sigma plus a we will put p, and instead of sigma plus b we will put q. Therefore e raised to minus p infinity e raised to minus infinity divided by minus s plus a plus 1 upon s plus a minus 1 upon s plus b plus e raised to sigma plus b e raised to j infinity s plus b. So we are going to put here q, this is q. Now we know that p is equal to sigma plus a is equal to sigma of minus a, and q is equal to sigma plus b is equal to sigma minus of minus b. When sigma is greater than minus a, that is p is equal to sigma of minus a, that is positive. Therefore e raised to minus p infinity is equal to e raised to minus infinity is equal to 0, and when sigma is less than minus a, p is equal to sigma minus of minus a is equal to negative. Therefore e raised to minus p infinity is equal to e raised to infinity is equal to infinity, and when sigma is greater than minus b, therefore q is equal to sigma minus of minus b is equal to positive. Therefore e raised to q infinity is equal to e raised to infinity is equal to infinity, and when sigma is less than minus b, q is equal to sigma minus of minus b is equal to negative. Therefore e raised to q infinity is equal to minus infinity is equal to 0. Therefore hence we can say that x of s converges whenever the value of sigma lies in between minus a and minus b. Therefore converges when minus a is greater than sigma greater than minus b, and does not converges when sigma is less than minus a and when sigma is greater than minus b. Therefore axis of convergence is nothing but sigma c1 is equal to minus a and sigma c2 is equal to minus b. Therefore when sigma lies in between minus a and minus b, the x of s is given as L of x of t is equal to x of s is equal to e raised to minus p into infinity e raised to minus j infinity divided by minus s plus a plus 1 upon s plus a minus 1 upon s plus b plus e raised to q infinity e raised to j omega infinity divided by s plus b. So we know that this is 0 and this one is 0, therefore these two terms become 0. So we only get 1 upon s plus a minus 1 upon s plus b. This is nothing but the values of x of s. Therefore for the two-sided signal, the ROC includes all the points on the s plane and the region in between the axis of convergence, that is sigma c1 is equal to minus a and sigma c2 is equal to minus b, as shown in the figure below. So I will draw here the figure. This is sigma, this is minus sigma, this is nothing but j omega minus j omega, this one is nothing but sigma c2 is equal to minus b, this is sigma c1 is equal to minus a. So we will draw it here, and the region of convergence lies between these two, minus a and minus b. Therefore this is figure of ROC of x of t, which is e raised to minus at u of t plus e raised to minus bt u of minus t. So by this method we can find the ROC of both sides of signal. Thank you.